All right. Good afternoon. My name is Myungjin Lee. I'm a bioinformatics scientist from Vaccine Research Center at NIH. In this presentation, I'm going to talk about a pathway of transition for HIV-1 involved trimer from prefusion-closed to CD4-bound open through an occluded-intermediate state. So my main topic of the research is HIV-1 vaccine development, and the entry process for the HIV-1 vaccine is starting from the pre-triggered state that the structural information is not known, and it goes to prefusion-closed confirmation that the GP120 is closed and locked, and once CD4 binds to the prefusion close, then the confirmation gets triggered to change its confirmation to the CD4 bound open that you can see on the right side. And I left space intentionally and continue to the prefusion phase. Once co-receptor bind to the GP120, then the GP120 falls apart and it goes to the intermediate state. Then you can see that viral membrane and host membrane starts to merge. And the last stage of the conformational change is the post-fusion, that the viral membrane and host membranes are completely merged, and the conformation of the envelope is completely changed to the 6-helix bundle. So this is the entire pathway of the entry process of HIV-1 envelope. And in this work, I'd like to understand the transition pathway in between the prefusion close to the CD4 bound open. So the question that I'd like to address is transition pathway between these two states with molecular dynamics simulation. So the simulation was done in this range in the orange box. And one slide summary of the MD simulation is that by experiment, just like cryo-EM or X-ray crystallography, we get a snapshot of the structure with protein or glycan coordinates. However, in the MD simulation, what you can get is, my video is not working, so. Okay. It's not working, but I'm going to skip this one. So in the MD simulation, sorry. It is supposed to run and then show the interactions between the protein and the protein glycans. That's right. The simulation starts from the prefusion close, as you see on the left side, with fully modeled and fully glycosylated structure with 3 CD4 bound. And the last step of the MD simulation is the same number of atoms and same number of the glycans, but only the difference is conformation. So it's completely open CD4 bound open conformation. And now I'm going to show you the trajectory that starts from the closed conformation with glycans, CD4, GP120, GP41. Initially, it is closed and compact. And once it goes to the opening process, you see that there's a lot of rearrangement happening, especially on the green glycans and also the top part of the trimer. And finally, it goes to the open conformation. And now I'm going to show you the same video without glycan and CD4 just to make it more clear. And I label the V1, V2, and V3 loops so that you can see the clear difference of these loops that are covered at the top of the trimer. Initially, it is closed and shaping a triangle. And once it starts to open, that it rotates outward and rearrange their loops, and it goes to the open conformation at the end. And same video, viewing from the side, you see the V1, V2, and V3 loops are covered at the top part of the trimer, and it is rearranging at the top of the trimer, and finally in the open conformation, it is completely extended. And now my trajectory is ready, and then I wanted to find out more interesting idea with this trajectory. So what I did was to collect all available HIV-1 complex structures that are published in PDB, and then align each of the PDB to the time frame, each of the time frame of the transition pathway, and calculate the RMSD to find out the best matching conformation to the trajectory. So based on that analysis, I found that most of the PDBs are aligned to the closed conformation, and there are some structures that are aligned to the open conformation. And it was really rare, but most interestingly, there are some structures that are aligned to the middle part. The first one is the antibody 1573 bound complex structure, antibody 1303, B12, and DHH51.3. So we define this area in the intermediate state as the occluded-intermediate state. And now I'm going to show you the trajectory again with the occluded-intermediate state labeled. So it is starting from the closed conformation. We are in the closed phase. And now from here is occluded-intermediate state. Then you see a lot of conformational change. And it is heading to the final state of occluded-intermediate and in the open phase. Without glycans and CD4s, closed phase is quite short. And in the occluded-intermediate, you see a lot of rearrangements. It's most likely local rearrangements instead of the global rearrangement that you can see the loops on the GP120s are mainly moving in this range of the state. And finally, it is entering to the open phase. The conformation is completely open. So we wanted to validate that idea if actually the 4 antibodies that we found targeting in the intermediate states actually induce the intermediate state. So we worked with an expert of ISMB to find out the state with and without the antibodies. The first panel is ligand-free, just HIV-1 envelope only. We found that there are 3 states exist, pre-triggered and steady for round open, and then prefusion-closed state. And once we add antibody 1303 and 1573, DHA51, we found that there's a huge peak shift from steady for round open to the occluded-intermediate. So we validate that idea that there is a new state present with these antibodies are there. We also did the same analysis with antibody B12. We also got the similar idea. So what did we learn from this study? Before this study, we knew that there are 3 states are there, and that is pre-triggered, and it goes to prefusion-closed and steady for bound open. However, with this study, we found that there's additional states available that is called occluded-intermediate, and it was validated by the ISMB analysis as well. So going back to the introduction page, the question was fill out the MD simulation that's occluded-intermediate. So we were able to fill out the entire pathway of the some part of the entry process. So the summary of the talk is MD simulation allows us to simulate prefusion-closed to steady for bound open with capturing key features of transition. And transition pathway by MD simulation reveals occluded-intermediate, and it was validated by ISMB data. And lastly, and most important thing is that occluded-intermediate state is the potential next vaccine target that we can further analyze and destabilize the structure to use the future immunogen. And I'd like to end my talk by showing my acknowledgement page. And thank you for your attention.